Hello, everyone. My name is Garrett Cowan. I am part of the Foresters team, and we are building reforestation robots that help reforest the forest, specifically in California after wildfires. We have four different robots. Mine specifically is called the Treebuddy Robot, and it actually involves with the actual digging of the hole and planting of the seed. So the robot consists of several different things. The Arduino Uno, of course, controls all of the actual motors and actuators. Here we have the right drive motor. You can see we have the left drive motor. We have the seed dispensing servo here. And we have the motor to actually run the auger. Then those are controlled by two L239Ds, which are placed, of course, on a small breadboard with power being supplied from Arduino and 9-volt power for the actual motors themselves from the 9-volt battery. And of course, we have the distance sensor here. The distance sensor actually functions to prevent the robot from running into anything. So we can see in the code here, which I'll pull up, that in the code, it has it to actually go in reverse. But here's my code here. See the receiver pin for our IR receiver, right? That comes from our IR remote, goes in through pin 7. So of course, we have all the different pins, and then just naming them. Of course, RDMN means right drive motor negative, right drive motor positive for RDMP. Then OGP is your OG positive, OGN is your OG negative, LDMN is your left drive motor negative. Then LDMP is left drive motor positive. And of course, there's trig and echo for your actual distance sensor. All right, and then you can see right here where a distance is less than 1.5, and then we'll actually trigger the motors to go in reverse, and then after for 1 second, and then once basically to get it greater than 1.5 inches away from whatever you're like a rock or something. So then once it gets greater than 1.5 inches, it will actually stop, and I will demonstrate that as part of this as well. You can hear that there's all the different portions of it, which the remote will actually tell the robot to do down here. So then now I will actually demonstrate the operability of the robot itself. All right, so we'll start the simulation, wait for it to boot up, and you can see the distance sensor is putting out. All right, so then we're going to go through 1. See, it actuates both motors to go forward. Okay, you can see now the right motor is going backwards, which will then cause the robot to actually turn right. You hit 3, now we're going backwards. Hit 4, now we're going to the left. Then hit 5, you can see the drive motors will turn off. And then the auger motor will actuate, and then we'll only actuate for 2 seconds, then we'll turn off. And I've done it for 2 seconds just as a kind of a predetermined thing for the amount of depth. More research would actually be needed in actual testing to figure out the actual time that would need to be required for the auger to actually run for proper seed planting depth. Unfortunately, I don't have those resources to actually do that right now. All right, and then we can see if we hit 6, it'll actually actuate the servo to 60 degrees with a delay of 500 milliseconds and then actually bring it back to 0. Now, in terms of the actual functionality of the distance sensor, so we're going to go ahead and put it in forward and then get it less than 1.5 inches. You can see now we're in reverse, and it will keep as long as your object is less than 1.5 inches. So say if you're walking towards the robot and you're staying within 1.5 inches, it will actually cause the robot to go backwards. Say if there's like an animal or something, to try to avoid hitting the animal. And then once it has greater than 1.5 inches, it will actually stop and go to 0. Then you can continue operating the robot as required. Yep, going through everything again. Then if you say, so we're going right now, that if we hit 7, it will then just go ahead and stop the robot altogether as kind of a safety feature. You can hit any other button of 0 through 9 besides 1 or 6. So it's 0, 7, 8, 9. The robot will stop itself there.